Hi everybody, Tesla technology researchers and radio amateurs. This is the second part of the video wired resonance phenomena with Tesla coils. In this experiment, we are adding a new feedback coil around the secondary Tesla coil. This is the new one. The primary, the new coil, and the secondary of the Tesla coil. This is the receiver coil where we are collecting electric power. The tabs of this coil, a 60-watt incandescent bulb is connected. From this tab we are giving backwards electric power to the Tesla coil through a capacitor 2 nanofarad. We are using here a primitive power supply, as you can see here, of half bridge and no stabilization at all. It's very primitive, very simple. Of course with an amp meter at the output to see how it draws. We are turning on the device now and we see how the bulb is shining. Double, maybe triple the brightness. You can see it very clearly. Now let's see how much power the system draws. Let's read the amp meter at the power supply. 1.1 amps, 1 amp and 10 milliamps, let's say 1.5 and 24 volts. I'm reading now. Let's say 25 to 26 watt. The whole system, as you see, is very stable, very easy to be built. The lamp is shining, and the goal is that if we return some power from the receiver to the source, I mean the Tesla coil as a transmitter, we can double or triple the electric power at the output of the receiver coil. Let's test now the Tesla coil, the catcher. This is a fluorescent lamp. Switching off the light to see it better. The incandescent bulb is shining. There is no high voltage at the receiver coil, but at the Tesla coil, the catcher, there's a plenty of high voltage, high power, high frequency. Where around the Tesla coil we can read high voltage, high frequency. Now with these sparks you can see how high is the voltage, radio frequency, and of course the output of the system. Return some power from the receiver coil to the Tesla coil back. It can amplify the output. That's it. Okay, now let's have a good look at what we did before. We have the new coil, the L4, around the L2, the secondary of the Tesla coil. The power comes from point B, the receiver coil, to point A, the Tesla coil, backwards. And the result is double or triple the power. This power back, of course, through the capacitor, 2.2 nanofarad, high voltage capacitor, 3 kilovolt. And its capacity depends of the frequency, the voltage, and the induction of the coils. It's very important. Okay, let's get back to the project and read the oscilloscope to see what we have. Now, the sine wave is the Tesla coil, and this one, the receiver. Let's put them together to see the phase, how it goes. You see it's a little slight away from the main, but the power is higher at the output. Don't forget that this time the bulb is shining. The frequency changes dramatically. Unfortunately, 4 megahertz, 25 kilohertz more, completely different. I am sure if you build this project, you will be surprised of the results of the power you may succeed at the output of the system. See my first video to understand how to build a catcher, a Tesla coil to this project. All this I described you before is a concept of Nikola Tesla. You have to read his patents to get more information about such projects you may build in the future. I have to tell you at the end that the coils L1, L4 around the L2 of the Tesla coil must be adjusted. I mean, the place they have to be must be aligned from you to succeed such a result I described you before.